All right, welcome back, students. In this video, we are going to cover lesson 10-4. This is inscribed angles. Previous video, we spoke about central angles. Central angles go, let's see, where am I at? Further down. Here we go. Central angles would be like an angle here from the center, but our inscribed angles are going to be deeper. So let's talk about this. Let me get situated really quick. I started the video without grabbing my pencils, and it's because I did 2 videos last night without sound. So, thank you. I'll have to look again to see exactly who, but thank you to whoever commented on the 10.5 video to let me know that I had no sound. Otherwise, I would not have known. And a lot of folks are just getting notes and not paying attention, and they're listening to their beats or whatever. So thank you. Let me see. Give me 1 second. Sorry. I promise I'm getting this thing together. Okay. All right, so inscribed angles. That's an angle that has a vertex on the circle, and the sides are contained in chords. So the whole thing's in the circle, but it's a deeper, instead of like a pizza cut or a pie cut, this goes all the way through. So if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of the intercepted arc. So like for here, so angle 1, we'll make it pink. Not sure if we're seeing the colors or not. That's something I actually said in the last video, but with no sound, you didn't hear anything. So let's see. Maybe that's a little better. All right, so this angle intercepts this arc. So for example, angle 1 is 1/2 the measure of AB, or the measure of AB is 2 times the angle. Okay. All right, so if 2 inscribed angles of a circle intercept the same arc or congruent arcs, then the arcs are congruent. So for B and C, they both intercept. So I'm going to do this. I'm going to make this pink here. This is arc AD. And angle B. So it's right here. And there's a little congruent symbol. So this makes angle B. And this makes angle C. So notice how orange and green both make the pink arc. So that means that B and C are congruent. Let's see. Stand by. Alright, so it's really, there's a congruent symbol there and there. And you'll see there. Oops, sorry. I'm not watching as closely as I usually do. Okay, let's get moving on. And I apologize. It's because I did the video last night. I thought it was pretty well, and then you have no sound, and so I did verify before I started. So I'm going to do example 1. You guys are going to do practice 1. There's an A and a B. Simple stuff. So here they want to know what the measure of arc CF is. So arc CF goes from here to here. And I'm going to follow this up to see what makes that arc, and it's this angle D, which is 40 degrees. So we found out that the inscribed angle is half the arc, or the arc. So CF is it's double the angle. It's double, we'll just say angle D. So that's 2 times 40. So CF is going to be 80 degrees. All right, still with me? All right, so angle C. Angle C, we're going to do it like this. We're going to go this way and this way. So notice it makes this arc, which is 98 degrees. I don't know where my red pen is. I don't mind pencil. In fact, I was dying for a pencil today at school because things are scarce right before spring break, I guess. All right, so we know that angle C equals 2 times, nope, it was 2 times the angle, it's 1/2 of the arc. So it's 1/2 of 98, or you can say 98 divided by 2. I just want you guys to know. All right, so half of 98 means angle C is 45 plus 4, that's 49 degrees. Okay, you guys over here, so measure angle B. Angle B is here, it's associated with that arc. They want arc BC, it's associated with that angle. You know the rules. Let's see what you can do. So we're going to move down the page, and we're going to look at example 2, and then you guys are going to do practice 2, and then I'm going to move to the next part of the page. So, example 2, find measure A. So, measure A. So, measure A is here. That's this. And we got D over here. Let's just see. You know, you guys know that they throw the example at us. So these guys should make the same arc. So that's going to make, let's see, how do we do this? So because they made the same arc, that makes these both, I'm just going to do it this way, that they're congruent. So measure of angle A is going to be congruent to angle D. That's going to be 5x minus 12, and they want angle A, so we're going to have to plug it in at the end. So, and they want, so angle D is 3x plus 2. Alright, so we're going to put these together. Now, we need angle A, so we're going to go over here and put angle A equals, what was it, 5. We're going to leave a spot for x once we find it, minus 12. We're going to go down, show that, and then at the bottom we will solve. This is kind of a new thing I've started doing. It kind of helps us a little bit. Let's just move a little. Okay. So, I'm going to just change colors. So, I'm going to subtract the 3. These cancel. This is 2x minus 12. And it equals, over here, these cancel to this, just 2. Make our equals a little better. So 2x minus 12, so let's add 12. Add 12. These cancel, and we'll move over here. So 2x equals 12 plus 2 is 14. Divide both sides by 2. X equals 14 divided by 2, which is 7. So we're going to just plug that in there. All right, so 5 times 7 is 35. 35 minus 12. Is it 12 or 2? Hold on. It is 12. Okay, so yeah, I did that wrong in the video last night anyway. All right, so 35 minus 12 is 23 degrees. All right, so down here, obviously these two guys, they make up this here, so they're congruent. Put them equal to each other, solve for x, plug it in for t. Hopefully you're listening. If you're not, then we'll see what happens. All right, flipping sides here. So now there's some stuff at the bottom here. I'm gonna post a video of another math teacher that does really well with these constructions. So once I get to the end of 10, I'll post it in the comments or figure out something. You know, you guys know I'm old, so You may, if you have any direction, then come see me. I need all sorts of help. If you guys have watched, you know that I need help editing and, I mean, really just help in general. I mean, you could just leave that statement blank like that and people would understand. Yeah, Mr. Whitlock needs help. Okay, so I drew this out. A couple of things I want you to know. Well, let me say what it says, and then I'll add my little 2 cents. So on this side, so an inscribed angle is a triangle. An inscribed angle of a triangle intercepts the diameter or semicircle if and only if the angle is a right angle. So G here, it splits this guy. So FJH, excuse me. It looks like half a circle to me, right? The semicircle is also half a circle. We talked about it in the last video. So if the arc is 180 and the angle is half of that, half of 180 is 90. So it's just math. All right, and if angle G is 90, then FGH is a semicircle, and then FH is the diameter. So something I want to write just above here. So diameter. So when your diameter is part of your triangle like this, it's always going to be your hypotenuse, because it's across from the right angle. I just like to bring that point out. Okay, one to the other side here. So quadrilateral is inscribed in a circle. So inscribed, so inside the circle. All right. I'm not going to color that in because I need to color the corners. All right, so in this quadrilateral, it's inscribed in circle A. Angle L and N are supplementary. So, parallelograms, opposite sides are congruent, but when they're inside a circle or they're inscribed, your opposite angles are supplementary. Okay? That's just for that particular situation. Okay, moving on. Just making sure I wasn't paused, man. I was going to be mad for a second. Okay, circumscribed circle of a polygon. So, inscribed meant inside the circle. Circumscribed circle is when the circle is around the polygon. So the polygon's inside. It would be but we say circumscribed circle because it's got a shape inside it. So circle contains all the vertices, so you see all the angles touch. The circumcenter of a triangle, so that's the intersector of all three perpendicular bisectors. The perpendicular bisectors are of all three vertices. That's the center of the circumscribed circle. So when you go over here and you make the perpendicular bisector for two of these sides, because if you have two, you have all three, then P becomes the point, which is going to be the center of the circle. So clarification, the polygon is inscribed inside the circle. The circle is circumscribed about the polygon. So, circumscribed, that's outside or about. And this is inscribed, so this is inside. So hopefully that's a good way to remember it. All right, so we're not actually going to do this. Again, I'm going to refer you, and you'll see here. I'm going to just go ahead and scooch just a hair so you can see video later. So step one, you make your perpendicular bisectors, and you label for AB and BC, and you label that point C. That's your circumcenter of your triangle, because that's going to be equidistant from this angle, and this angle. So when you go, it looks like that at the end. All right, step two, place the compass at point B. So, point P. So you put the sharp end here. You adjust the setting so we're at A, and so that the pencil is at A. So without changing, say that a lot, without changing. So we're set here. This is the sharp end. I know I'm using the pencil and I apologize, but so you draw the circle. AP is your radius. So it'll be around the circle. So you would go, and then you end up having to switch hands to go all the way around. So again, down here it's saying to use that. I'm gonna show you guys a video. It's really about the steps, and I can show you how to answer the question for the steps. It's really, if you guys pay attention to what it's saying, it's not difficult. You don't have to know everything to know some things. Excuse me 1 second. Okay, so when constructing the circumscribed circle of a triangle, so remember, that's what you're doing. Why do you construct perpendicular bisectors of the two sides? Pretty sure we talked about why, but let's look at these answers, and we're going to start from the bottom and go up. All right, so from here, because the circumscribed circle only works with equilateral triangles. Well, that's not true. We didn't say anything about that, so that's a big fat no. C, because the compass width represents the distance from the center to each vertex, which must remain the same of all points of a circle. All right, well, we won't say no to that. We're just going to put a little mark, because that is, there's some truth to that. Okay. B, because the perpendicular bisectors will no longer intersect if the compass width changes. Okay, well, I don't know what any of this garbage means, so it's a definite no. And then A, so because changing the compass width would move the center of the circle to a different location. And I feel like these are different than what we had in class. But, okay, so yeah, if you do move it, it's going to change it, but that's not why we do that. It's because all the points must remain the same for the circle. So if it's equidistant from each vertex, it's going to go around it and touch each vertex. So the answer ends up being B, and I'm just going to highlight it. So like this. All right, so got to be kind of quick. Got a little dinner deal to go to. I'm going to try to paint a little picture down here real quick. Happy little accident. Sorry, yeah. Bob Ross is not in my repertoire of impressions. I don't know how many I've actually done on here, but anyway, we'll get to it in a minute. Maybe I'll throw a Kermit or something at you. I don't know. All right, example 4. Find the measure of angle K. All right, so remember I told you if the diameter is in your circle in this situation, this is your 90-degree angle. So this guy and this guy, the whole circle is 180. If this is 90, that makes these two worth 90. So we're going to say angle K plus angle M equal 90. And then we'll find angle K by plugging in X after we find it. So it's going to be 5X plus 4 equals 8X minus 10. Nope, actually, messed that up. What did I just say? They're equal to 90. We got to add them together and put them equal to 90. Equal to 90. So, I'd rather make these mistakes for you and have you. So now, all these guys are on the same side. Sometimes that throws you guys off. If something's equal to something, let's put all our folks that look alike together and then solve. So 5X and 8X, I'm just going to circle them, and they're both positive. That makes 13X. And then I have a negative, let me see, positive 4, nope, that's a negative, so that's what made it, yeah. So negative 4 and negative 10 make negative 14. Again, they're equal to 90. So because it's negative, we're going to add and make it positive. Yeah, okay. Making sure I did it right the first time. Again. All right, 90 plus 14 is 104. These cancel, so we got 13x equals 104. We need to divide both sides by 13 because we want x alone. X equals 104 divided by 13 is 8. Okay, so let's go down here. They wanted angle K. Angle K equals 5 times x minus 4. So x was 8. I'm just going to finish this off with this. 5 times 4 is 40. Minus 4. 40 minus 4 is 36. So angle K is 36 degrees. All right. Help you out a little here. This is your diameter, so this is your 90. So either add them all, include that as 90, or just say 180 minus 90 equals 90, and then add them, do that way. They're only asking for x here, so you're just solving for x. Much easier. The bottom, this will finish off. Just double check. Yeah, this will finish off this video. I have another video coming at you later. I did the same thing last night. You guys couldn't hear me. Hopefully this goes well, and if I can try to, I'll get 6 and 7. Yeah, I said 6, 7. 10.6, 10.7 finished tonight. We're going to try to review tomorrow in class. Not sure about you other guys, but reach out to me either in Focus or in Teams, or comment on the video if you need anything. Even if you're in other classes, I don't mind helping. Usually tutor on Mondays, so we're going to pick back up after spring break. I'll let you guys know exactly what day, but anyway. Example 5. So we want to find angle F, and then over here, the check for you guys, you want to find angle G. So we found out that when the shape is inside the circle, that opposite angles are supplementary. All right, so because they're supplementary, they equal 180. So one thing you'll notice, so your opposite sides are x's, your opposite other sides are y's. So for F, we're going to be dealing with the y's, and for the G, you guys are going to be dealing with the x's. So just understand, add them together, put them equal to 180. That's how you're solving, and we're going to plug it back in. So for us, we're looking for F, so F and D equal 180. So angle D plus angle F. All right, angle D is 5y plus 16. F is 3y, so plus 3y plus 4, equals 180. So this guy plus this guy equals 180, because opposite sides are supplementary. You're going to do the same over here with your x's. So I'm not going to you just solve for angle G, so plug it back in to G once you're done. All right, so 5y, 3y make 8y. 16 plus 4 is 20. They're both positive. We got 180. So because 8y plus 20 equals 180, we're going to subtract 20. Subtract 20. These cancel. 8y is coming down. 180 minus 20 is 160. We divide both sides by 8. We're going to find that y is equal to 20. Now, they want angle F. Angle F equals 3 times y plus 4. So y was 20. So 3 times 20 is 60 plus 4. 60 plus 4 is 64. So angle 4 is 64 degrees. That leaves you guys finding G. Shouldn't be an issue. If you have an issue, let me know. If you have any problems and you need me, again, Focus, Teams, or comment to the video. Again, shout out to whoever, and I'll find you. Not stalkerish, I'll find you to thank you. So until next time, have a good night.